Hello, we are part of the SEAS 2022 Meteorite team, and our project is titled Presolar Grains, a window through space and time. Following their formation in stars, heavy elements were scattered throughout the universe via supernovae and stellar winds. Heavy elements that were present during the formation of the solar system have been preserved as presolar grains in primitive meteorites. Identified by their anomalous isotopic composition, presolar grains stand out from other matter found naturally throughout the solar system. Isotopes found in these grains have been preserved since the solar system first formed, and therefore vary from uniform isotopes of the present. Because studying presolar grains essentially enables scientists to look at distant stars through a microscope rather than a telescope, many significant conclusions can be drawn from them.
Presolar grains are microscopic particles that were condensed during the formation and collapse of stars. These grains come in many different types. Diamond, silicon carbide, graphite, and oxides are the most common. Presolar grains are found all throughout chondritic meteorites. However, they're most commonly analyzed when found within the chondrules and refractory inclusions. Scientists analyze many different aspects of these grains, most commonly the isotopic compositions. The anomalous compositions found in presolar grains help to identify the meteorite's origin, give evidence towards an isotopically heterogeneous presolar nebula, and detail nucleosynthesis.
We gathered lots of information to make this project possible, but these are just some facts we found interesting during our research. With the size and the unique properties of the presolar grains, it's hard to identify them just by their looks. Only about 5% of meteorites found on Earth have traces of presolar grains. Scientists can locate presolar grains through the unique isotopic ratios on the chondrites of a meteorite. These 4.7 billion-year-old grains need special equipment to be able to carefully examine them. The instruments include secondary ion mass spectrometry, scanning electron microscope, transmission electron microscope. NanoSIMS is the main device used because it specializes in isotopic ratios along with other qualities.
The presolar grain field of study is providing optimistic results for the field of astrophysics. Further research promises a greater understanding of stars' evolution, both stellar and nuclear synthesis. Nuclear synthesis being the production of chemical elements from simple nuclei, commonly in stars. It similarly aids scientists' understanding of meteorites' origin based on the composition of those presolar grains and forms more accurate stellar formation and evolution models. An improvement on the process to study individual grains is needed because of the difficulty to analyze smaller grains. Studying singular grains provide more information on the individual stellar formation since the origin of all presolar grains heavily varies.
Because of their distant formation and preservation, presolar grains contain valuable information. First of all, examining the isotopic composition of the grains tells scientists the type of stars from which they came and can teach them about processes that occur within these stars, such as nucleosynthesis, mixing that occurs during supernovae, and the star's galactic history. Furthermore, presolar grains are strong evidence towards the heterogeneity of the solar nebula.
Both of these graphs show the isotopic compositions of presolar grains, focusing on nitrogen and carbon. The right graph shows a wide range of grain types. The significance of this graph is that it shows the anomalous isotopes such as carbon-13 and nitrogen-15 are much more prevalent in the presolar grains than typically throughout the solar system. These solar lines show the isotopic ratios of most matter throughout the solar system. So the immense amount of data under these lines represents the prevalence of isotopic anomalies. The left graph with presolar grains from the Hingzhen meteorite have mainly type X1 grains, which are not anomalous in their carbon compositions. This corresponds to the X1 grains in the right graph. These X1 grains, though, show an immense abnormality in their nitrogen isotopic compositions.
Our team reflected on our experience here at the SEAS internship. We all agreed this was a unique experience and we learned skills that will stick with us for our future careers.
The whole team says thank you to all sponsors of this program, including our mentor, Ms. Foxworth. Are there any questions?